The topic is computer modeling, analysis of the main information properties of Memristor and its application in secure communication system. In 1971, Leon Chua suggested the existence of another basic element of the electrochemical system, which relies the connection between magnetic flux and charge. In 2008, scientists managed to discover a new component. This component is called a memristor. This term was formed as a result of merging the words memory and resistor or electrical resistance. This term refers to a bipolar device, the electrical resistance of which varies depending on the amount of charge flowing through it. The resistance of the memristor is called the memristor M, which is defined as a ratio of the change in the magnitude of the magnetic field flux to the change in charge, and its value depends on how long the circuit electric current flows through the memristor, that is, the amount of charge that passes through it. The main advantage of a memristor is properties that are not stored in the form of charge. These properties differ from most types of modern semiconductor memory elements. This is the main advantage because it is not afraid of charge leakage, which is the main evil that everyone wants to get rid of when switching to nano chips. Another advantage of the memristor is energy independence. These properties ensure that the memristor is stored at the sometimes is the exciting materials used to make it. The successful production of the memristor by Hewlett-Packard greatly increases the interest of researchers in the memristor. Many scientists began to use the memristor in analog systems and in digital media. Others have used memristors as resistive memory modules and logic programs. The potential of using a memristor in neuromorphic applications has also been studied by many researchers. The linear behavior of memristor information properties is described by next equation system 1. A chaotic time series is a sequence of data that exhibits chaotic behavior over time when plotted. A characteristic of chaotic signals is that they are sensitive to initial conditions. This means that a small change in the initial conditions can cause the results to look very different over time. Chaotic signals often look chaotic and unpredictable. They look like random noise, but they have an underlying deterministic dynamic. Time series for x, y, and z coordinates are shown in figure 1. The parameters values are presented, number of iteration and equal 10,000. For modeling was used modern software environment LabVIEW. Another information property of memristor are phase portraits that shown in figure 2. Phase portraits in XY, XZ, and YZ projection. Masking and decryption of the information using memristor. Protection information from unauthorization access is one of the most pressing tasks in telecommunications. Often in telecommunication systems, we deal with the digital signals as an information carriers, for which there are already effective protection methods based on cryptography algorithms. In the case of analog signals, other methods of information protection are required, one of which is the masking method. The essence of this method is that it is necessary to find a specific signal source that has the same spectral properties as the protected information signal. Accordingly, if such a signal is mixed with the information signal, the resulting signal turns out to be uninformatable, and as a result, the information signal turns out to be protected. The last decade has been known for extreme interest in the possibility of using dynamic chaos for data encryption. At the conceptual level, there is a particular relationship between chaotic systems and cryptographic systems. Therefore, in nonlinear dynamics and in cryptography, nonlinear transformation of information materialized. Such a transformation is deterministic, for example, performed by a computer. On the other hand, it must be unpredictable for the external observer. Therefore, the word deterministic chaos is quite suitable for cryptography. The block schema demonstrates process of transmitting and receiving information using chaotic signal for masking and decryption in figure 3. In this case, the transmitter and the receiver systems are identical. The masking of the information based on nonlinear properties is provided by blending information with the chaotic signal that was generated of the different coordinates. As an information, there was used a sinusoidal signal with amplitude of 5 volts and system parameters. Number of iteration n equal 10,000, dynamic variables x, y equal 1. Dynamic variables are system and system parameters are the case for the masked information. Algorithm for the decryption has opposite effect. The program interface, which demonstrates the masking and decrypt of the information based on the properties of Memristor system 1, is presented in figure 4. In this slide, present conclusions. Thanks for attention.